Hey guys, we are going to do a quick notes today on Chapter 7, Section 7. We're going to go over a couple different triangle congruence theorems. Let's get started. So far, we have seen that, we've seen two methods for determining that triangles are congruent. You got the angle side method, right? That looks like this. You got two angles and a side not between the two angles. And when they are congruent, the two triangles are congruent. We also have the angle side angle theorem. But my question is, are these the only ways to determine if two triangles are congruent? And I want to look at one of them and see. So to determine if two triangles are congruent, here's why these theorems work. The reason that the angle side angle congruence theorem works is because there is only one possible triangle that can be drawn when you lock two angles and the side between them. And I want to show you what I mean by that. So down here, I have an example of the angle side angle theorem, and I am claiming that there's only one possible triangle that can be drawn. If I say that this angle is 50 degrees, so I'm locking it in, and I'm locking this angle in at 60 degrees, and I'm locking in this side length at 10. All right, so those have to stay the same. So this angle is 60, this angle is 50, and this length is 10. I claim that when these three things are locked, there is only one possible triangle. Right? The only part that I'm allowed to mess with is the two sides that are not completed. All right? I can't mess with the two red angles, and I can't mess with the side that's 10. But I can mess with the other sides. So let's look at finishing the other sides. And if I finish this side, they're going to look something like this. Right? And what I claim is that this is the only way to finish the triangle. If I take this second triangle and I try to finish it by extending this side and extending this side, I claim I get exactly the same triangle. There is not a different way I could finish the triangle, right? Certainly, this angle has to be 70 so that all three angles add up to 180. And I claim this spot will be the same no matter what. There's no way to adjust those lines so that they end up at a different spot because I'm not allowed to adjust the angles. So the lines have to end up at the same spot. And therefore, you end up with two congruent triangles. However, let's look at a different method. So there's a different method over here. And on this one, I'm going to lock in the bottom. I drew it in red just because I wanted to put the stuff in red that was locked. Let's say that has a length of 15. And I'm going to draw a second side here, but I'm not going to lock in its length. So let me grab a segment. You could do this on paper. And I'm going to draw on a side here, but again, I am not locking in the length. I'm just going to make it a long side like that. But what I do want to lock in is I am going to lock in the angle. So I'm going to make this angle, let's say 40 degrees. I am locking that in. So my things that are locked are the blue things, right? The 40-degree angle, I am not allowed to mess with. The length of this red line at the bottom is 15. I am not allowed to mess with that. And then I'm going to lock in one more thing. I'm going to lock in one more side. I'm going to take this segment, and I'm going to say that segment, say, has a length of 12. And I'm locking in this length of 12 as the third side. But watch. I can take this length of 12 and I could put it here. Boom. So that side now has a length of 12. And it is locked in, so let's leave it. I'd like it to be red, I think. So I want to lock in. I want to make the sides red that are locked. Okay, so that side is locked in at 12. So what I'm trying to show you here is I've got an angle locked and I've got two sides locked. This would be side, side, angle. Be careful how you write that. Side, side, angle. Notice the angle is not between the two sides. And I'm locked right there. Well, I'm not. The two sides are locked. But you know what's not locked? This angle is not locked. All right? And so watch what I can do with this side that is 12. I'm going to see if I can, I'm going to take this side and I'm going to try to copy it. So watch. I can take this side that is 12 and I can take this angle right here that is not locked and I can make that angle be like a door hinge where I'm going to swing the side around. The side is like a door. And as I swing it around, that did not work like I wanted to. As I swing it around, it also fits there. So what I end up with is this side, this side is 12 also. And I lost my line there, sadly. So I had it here. All right, that was 12. All right, so I can take that segment that is 12 and I can put it in two different places just by taking this side and swinging it up there. So do you see, I have a 40-degree angle and a side that's 15 and a side that's 12. So I have this side-side angle, locked in place, but that actually gives me two different triangles. I have this triangle that's, oh man, not what I wanted to do. Do that. I have this triangle that's green, hopefully. All right, that's one triangle that is 40, 15, and 12. And then I have another triangle that is purple. That is 15, 40, and 12. Two different triangles, and they have exactly the same angle, side, and side. All right. My point is, since there's two different triangles you can make that have two sides equal, and they have this angle equal, then that is not a good theorem. That does not prove that triangles are congruent just because they have two sides equal and an angle equal that's not between the two sides. Because there's two different triangles you can make, so it doesn't, they wouldn't have to be congruent to each other. All right, we're moving on from that. Here we go. There are, however, three ones that we can do. All right? So the first one is quite easy. If that was equal to that, and that was equal to that, and that was equal to that, this is known as the side, side, side theorem, then the triangles would be forced to be congruent. And we might say something like, if all three pairs of corresponding sides are congruent, then the triangles are congruent. All right, this is known as the side, side, side congruence theorem. Again, there are 3 parts equal to 3 parts. And if the 3 sides are equal to the 3 sides, then all the angles have to be equal as well. You get the angles for free. That's one. Next one. If I had this side equal to this side, and this side equal to this side, and this angle equal to this angle, this would be known as the side-angle-side congruence theorem. Then the triangles would be congruent, which is to say, if 2 sides and the included, remember what the word included means. Included means between. If the 2 sides and the included angle, GLE, and the included angle are congruent to the corresponding 2 sides and included, angle, then the triangles are congruent. And again, there are 3 parts equal to 3 parts. All of these theorems require 3 parts to be congruent, just in a specific order. This one is 2 sides and an angle, but the angle must be between the 2 sides. And this brings us to the last one on the back here. This last one involves if you have a special case of right triangles. So our first thing says if both triangles are right triangles and one leg and the hypotenuses are congruent, then the triangles are congruent. So I have one leg equal to one leg. Remember, the leg of a right triangle is, well, both sides that make the right angle are called the legs. And the hypotenuses are equal. Remember, the hypotenuse of a right triangle is the side opposite the right angle. So I have a leg equal to a leg, and I have the hypotenuse equal to the hypotenuse, and it's a right triangle, then the triangles are congruent. And I want to point out again, this still requires 3 parts. Although it's not really parts, it's, you have to have right triangles, and you have to have hypotenuse equal hypotenuse, and leg equal leg. So there are 3 things, again, that have to be true for this to work. And you can see here I've thrown in the definition of a right triangle in case you need to use it in a proof. If a triangle contains a 90-degree angle, then it is a right triangle, right? You'll need that probably on your homework at some point. All right, so let's look at a proof real quick that does this. This should be a pretty easy proof. I have been given some stuff, and I want to prove that these 2 triangles are congruent to each other. So I've been given that BC is congruent to DC. Let's go ahead and write that down. BC is congruent to DC, and that was given. And I've been given that AC is congruent to EC. Let's go ahead and mark that down. Now, you could actually put those in the same statement and just have one statement that says this and this are true, and it's given. I chose to do it in 2, but it's no big deal either way. And the other thing you should do is you should mark stuff off on your diagram. Now, remember how we make a plan. Do you see these? Do you see the triangles and how we can prove they're congruent? right? We have 2 parts equal to 2 parts. We need 1 more part. And do you see what it is? I'm sure most of you probably do, right? This angle is equal to this angle, right? We know why that's true. So I can actually say that angle BCA is congruent to angle DCE. And that is true because of the vertical angles theorem. And I now have 3 parts equal to 3 parts. And most importantly, they are a specific 3 parts that work. They are a side, an angle, and a side. So because of the side angle side congruence, these triangles are going to equal each other. If you are trying to prove that 2 triangles equal each other, you are always going to use one of our 5 theorems that we now have. And I'm going to review those real quickly here. We now have 5 theorems. We have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Now I write them like this on purpose because it's kind of how I remember them. You got 3 sides, you got 2 sides, and you got 1 side. 3 sides has to be side, side, side. 2 sides only works when the A is in the middle, because if you put the A on the front, not so good. And then, of course, we've got, with 1 side, it works whether that side's in the middle or not. So there's those 4, and then you got the special one, hypotenuse leg. All right, so I want to go through these 3 quick examples. Do these have enough information to say that the triangles are equal? So you might try them on your own first and then ask, and then flip on the video and make sure you got it right. This first one, of course, the side down the middle is equal to itself. So these are congruent by side, side, side. This next one, I don't know if you thought about it or not, but it's a tough one. This next one is actually no.